Hey everybody, so it's our 8th day of Unit 0, and today is September 2nd, 2020. Going through our class norms, I'm not going to read these again because they're the same things, just make sure we are abiding by them. And then let's get started. Our vocabulary. So first we have the greatest common factor. That is the biggest number that will divide two or more other numbers exactly. Then we have our least common multiple, which is the smallest number that is the multiple of two or more numbers. And then we have prime numbers, a number that has exactly two factors. Next up, we have our objectives. Alright, so let's get started with our least common multiple.
What is the least common multiple of 36 and 12? So, and they say another way to say this is LCM in parentheses 36 and 12. And this is literally saying what's the least common multiple of 36 and 12? Well, this one might pop out at you because 36 itself is a multiple of 12. And 36 is also a multiple of 36. It's 1 times 36. So the smallest number that is both a multiple of 36 and 12, because 36 is a multiple of 12, is actually 36. There we go. Let's do a couple more of these. That one was too easy. What is the least common multiple of 18 and 12? And they just state this with a different notation. What's the least common multiple? Or the least common multiple of 18 and 12 is equal to question mark. So let's think about this a little bit. So there's a couple of ways you can think about. So let's just write down our numbers that we care about. We care about 18 and we care about 12. So there's two ways that we can approach this. One is the prime factorization approach. We can take the prime factorization of both of these numbers and then construct the smallest number whose prime factorization has all of the ingredients of both of these numbers, and that will be the least common multiple. So let's do that. 18 is 2 times 9, which is the same thing as 2 times 3 times 3. Or 18 is 2 times 9, 9 is 3 times 3. So we could write 18 is equal to 2 times 3 times 3. That's its prime factorization. 12 is 2 times 6. 6 is 2 times 3. So 12 is equal to 2 times 2 times 3. Now the least common multiple of 18 and 12, let me write this down. So the least common multiple of 18 and 12, 18 and 12 is going to have enough prime factors to cover both of these numbers and no more, because we want the least common multiple or the smallest common multiple. So let's think about it. Well, it needs to have at least 1, 2, a 3, and a 3 in order to be divisible by 18. So let's write that down. So we have to have a 2 times 3 times 3. This makes it divisible by 18. If you multiply this out, you actually get 18. And now let's look at the 12. So this part right over here, let me make it clear. This part right over here is the part that makes up 18, makes it divisible by 18. And then let's see, 12, we need 2 2's and a 3. Well, we already have 1 3, so our 3 is taken care of. We have 1 2, so this 2 is taken care of. But we don't have 2 2's, so we need another 2 here. So notice, now this number right over here has a 2 times 2 times 3 in it, or it has a 12 in it, and it has a 2 times 3 times 3, or an 18 in it. So this right over here is the least common multiple of 18 and 12. If we multiply it out, so 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is equal to 36, and we are done. Now, the other way you could have done it is what I would say just the brute force method of just looking at the multiples of these numbers. You would say, well, let's see, the multiples of 18 are 18, 36, and I could keep going higher and higher, 54, and I could keep going. And the multiples of 12 are 12, 24, 36, and immediately I say, well, I don't have to go any further. I already found a multiple of both, and this is the smallest multiple of both. It is 36. You might say, hey, why would I ever do this one right over here as opposed to this one? A couple of reasons. This one, it's fun because you're actually decomposing the number and then building it back up. And also, this is a better way, especially if you're doing it with really, really large and hairy numbers. Really, really, really large and hairy numbers where you keep trying to find all the multiples. You might have to go pretty far to actually figure out what their least common multiple is. Here, you'll be able to do it a little bit more systematically and you'll know what you're doing.
Alright, so just to summarize those steps that he went over in the Khan Academy video, is to first we're going to list the prime factors of each number. That's when he drew those lines underneath both numbers and then factored them out. Then you multiply each factor the greatest number of times it occurs in either number. If the same factor occurs more than once in both numbers, you multiply the factor the greatest number of times it occurs. Then we're going to check our answer by checking to see if your answer can be divided evenly by both numbers. Next, we're going to talk about greatest common factor.
LOL, aka ASAP, TTYL, OMG, YOLO! And last but not least, GCF. Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're going to add another acronym to the list, GCF, or Greatest Common Factor. All right, today is all about the greatest common factor, or more commonly known as the GCF. So first, let's talk about what is the greatest common factor, and it's pretty simple. If you just look at the name, the greatest common factor is just the greatest of the common factors between two or more numbers. That's all it is. You find the common factors, and then whichever one's the greatest, that's your GCF. Let's try an example. There's a couple ways we can find the GCF. The first one we're going to go over is by listing factors. So I'm going to find the GCF of 24 and 40. First, I'm going to list the factors of each of those numbers. So 24, I'm going to go through my factor pairs. So first, I always start with 1 and 24. It's an even number, so I know 2 works. 2 times 12 is 24. I know 3 works. 3 times 8 is 24. Also 4 times 6. No 5, and then I'm back to 6. So those are my factors for 24. I'm going to rewrite them in order down here. So for 24, my factors are 1, 2, 3, 4, 6, 8, 12, and 24. Okay. Next, I'm going to list my factors of 40. I'll do it in blue. Let's see. So same thing. For 40, always start with 1 and 40. It's also even, so 2 is going to work. 2 times 20. 3 is not a factor of 40, so I'll skip that. 4 is. 4 times 10. 5 is, because it ends in a 0, so I know 5 works. 5 times 8 is 40. 6, no. 7, no. We're back to 8, so we're done there. I'm going to do the same thing and list my factors down here. So 40 in order. 1, 2, 4, 5, 8, 10, 20, and 40. Those are my factors for 40. Now, I've got my factors. Now, as the name says, GCF, greatest common factor. Common means it's the same in both numbers. It's a factor for both 24 and 40. So what I'm going to do right now is I'm going to circle my common factors. Well, 1 is common. They're in both. Same with 2. Same with 4. 3, no. 5, no. 6, no. 8, yes. 10, no. 12, no. 20, 24, 40. So those are all my common factors. 1, 2, 4, and 8. And then all you got to ask is, well, which one is the greatest of the common factors? And obviously 8 is the greatest. So my final answer, the greatest common factor of 24 and 40 is 8. GCF equals 8. Okay. Let's find the GCF using another strategy. For example 2, we're going to find the GCF by prime factorization. So we're going to do the same exact problem and just solve it a different way. Find the GCF of 24 and 40. We're going to use prime factorization. So first, I'm going to use a factor tree and figure out what the prime factorization is of both numbers. If you want to pause it and try to do it on your own, go for it. So for 24, I've got lots of options of where to start. It's always easy to start with 2 when you have even numbers, so I'm going to do that. 2 times 12, that's prime, so I'm done with that. 2 times 6, done. 2 times 3, done and done. So my prime factorization of 24 is going to be 2 times 2 times 2 times 3. I'm going to leave it expanded like this instead of writing 2 cubed, and you'll see why in a second. Next, let's do prime factorization of 40. 40, I'm going to start with 2 again. 2 times 20 is 40. That's prime. 2 times 10 is 20. There's a prime. And then finally 2 times 5 is 10. And those are both prime. So my prime factorization of 40 is 2 times 2 times 2. 2 times 2 times 2 times 5. So I have my prime factorization of 24 and 40 done. Now, all I need to look at is see what prime numbers are in common for both of the prime factorizations. So you can see they both have a 2, they both have another 2, and then they both have a third 2. So all we have to do to find the GCF now is multiply. So they've got 1, 2, 3 2's in common. So 2 times 2 is 4 times 2 is 8. So again, the GCF of 24 and 40 is 8.
So those were 2 ways that we can find the greatest common factor. So our first step in that is to list the prime factors of each number you're trying to find the GCF for, and then to multiply the factors that both or all of the numbers have in common. Alright, so now we're going to move on to our example. So our example here is just like the exit ticket, but with different numbers. It's asking Brenda and Angel both did their laundry today. Brenda does laundry every 12 days. So I'm going to circle that number because it's a word problem and we need to know all our numbers in here. And Angel does laundry every 14 days. How many days will it be until, I don't know why it says Tim, but let's just say Angel and Brenda both do laundry on the same day again. So in this, we're looking for the lowest common multiple of 12 and 14. So what we're going to do is we're going to factor out both numbers. So I'm going to factor out the 12 over here. So we go 2 and 6, factor out 6, 3 and 2. And then over here 14 is simple, just 2 and 7. So we need all of these in our answer, but we're looking for the least common multiple. So we're going to list out 12s. So 12s is 2 times 2 times 3. And then 14 is 2 times 7. So we don't want too many 2's. So then our LCM comes out to 2 times 2 times 3 times 7. We don't need 3 2's, because this 2 will cover each other's. So then our LCM of 12 and 14 is 2 times 2, which is 4, times 3 is 12, and then bring that down, 12 times 7 is 84. Our answer is 84. All right, so that was all for today. Don't forget to, if you were in the live session, you do not need to do the independent practice, but you can for some extra practice, and then go straight to the Edulastic exit ticket. If you have trouble, please G-chat me. Truman State, your next class is at 10:20, and UCO, your next class is at 12. Stay in the Zoom call if you'd like to practice with Mr. Juarez. Have a great day.